This is Shelley Hughley with Southwest Farm Press, and I am once again at the Lubbock Classification Complex in Lubbock, Texas. And joining me are Scott Fanning, the engineer of record, and USDA AMS Cotton and Tobacco Deputy Administrator Darryl Earnest. Tell us a little bit about how progress is going, and then Scott's going to talk to us about the energy efficiency of this classification complex.
Well, thank you, Shelley. It's good to be back again after a few weeks. Since the last time I was here, progress has been going really well. We've made a lot of structural progress. It looks a little similar to the way it was when we were here before because a lot of the interiors are not quite there yet, but a lot of the infrastructure has been put in. So we're pleased with that. We're still working towards a fall completion. I don't think at this time we're going to be able to actually utilize this facility this fall in time for the crop. We're still looking at that, but right now it looks doubtful, but that's okay. We've got a backup plan, and that backup plan is we'll remain in our current facility on Ironton Avenue and class the crop there while we're finishing up here and making our transition. So I'm real happy to have Scott Fanning here with us today. Scott is the engineer of record for this project, and he has designed most of the cotton classification facilities that we have nationwide. And a really unique component of this facility is its energy conservation component that we have really stepped up on this job, maybe compared to some of the ones in the past. So
Darryl's vision for this building would be to have the most efficient classification complex facility in the nation. And so there are three things I would say that we did that kind of go toward that goal. The first is the office area that we're standing in now has a variable refrigerant volume system. And basically it is a system where there are cassettes in each office where you can individually control the temperature, but everything is only uses the amount of energy that it needs. Everything is variable speed. So it's the most efficient type of air conditioning system for an office. And that's good, but it's also good that we have it separate from the system that we have out here. And that's because we can run the office and take that equipment down and work on it while we still have our staff up here. The second thing I would point to is we got a free cooling cycle whereby we use, it's cold when they class cotton in the fall. And so what they do is when it's cold, we can use the low temperature outside in a heat exchange process to cool the building and not run the compressor on our air conditioning system. So that's a very efficient thing we can do because we're up here on the high plains. The third thing I would point to is that we have a heat recovery system where we use, when we are running the chiller, when it's a little warmer, we can use the heat that compressor rejects to provide heat for the building for reheat, because we have a process where we control very tightly temperature and humidity. So all the light fixtures in the entire building are LED. So on dollar per square foot per year in terms of energy costs, this will be the flagship of the entire fleet of classroom offices. So.
yeah, and that's one thing we were going for this time, Shelley, is we wanted to take advantage of as much energy conservation as we could, from not only the lighting to the materials that we're using in the building, to Scott's point, all the equipment kind of working in sync. So in the past, we've explained a little bit about our automation. We've explained a little bit about kind of how some of our features in the building. But this is going to be a very energy efficient, very tight building, and one that we will use as a model for any renovations or any new ones that we do in the future.